Welcome to Climate InnoPod. I'm Dayu.
I'm Ellen, and now let's delve into the spirit of climate innovation. Today, we are pleased to have Joseph Kao join us on Climate InnoPod. Joseph has over 10 years of experience in hardware R&D and project management. He worked for renowned companies such as Dow Chemicals, Carbon 3D, Apple, and Meta. And he managed projects like Apple Vision Pro and Apple Zero Waste initiatives. Joseph was also a material scientist. He invented and commercialized a variety of state-of-the-art polymer. His work includes 5 commercial products and 6 granted patents. He holds a PhD in material science from UC Berkeley and a bachelor from UIUC. While Joseph pursued his personal and professional growth in Stanford Business School, he found his enthusiasm in circular economy and waste management, with a focus on EV battery reusing. So welcome.
Glad to be here. Thank you for the invitation, Ellen.
Thank you, Joseph. You have such a rich career trajectory. Let's begin with your transition. You started as a material scientist with hardcore training, then moved on to business R&D and business management roles. And you are quite successful there. So what made you decide to take a career break and transition into the impact entrepreneurship space?
I think I will start with my upbringing in Taiwan. I grew up in Taiwan and raised by my grandmother. She came from mainland China and survived the Chinese Civil War. It was tough on her, and she was literally living on waste resources to survive the war and escape to Taiwan. And I was raised by my parents and her. And growing up, she just instilled me with this idea on circular economy. She always says that your waste is someone else's treasures. So I actually volunteered a lot with her on just neighborhood recycling growing up to help the community and clean up the streets, things like that. And that's one of the reasons I got super interested in material science. And having both of my parents being material scientists and chemists also helped a lot as well. But it's because of that experience, I got super interested in polymer or plastics. So I decided to pursue my PhD in polymer science at UC Berkeley. I work on several projects on polymer, including biodegradable plastics, also nanocomposite, where I manipulate the nanoparticles in polymer film. And that research actually got a lot of interest from consumer electronics industry, and Dow Chemical was one of them. At the end of the PhD, I decided to just go to Dow Chemical. And I was pretty lucky. You mentioned about business R&D. It has some luck in there. So I started the project with my invention in Dow Chemical on the polymer composite for the flexible hard coat. Many of you may have seen the foldable phone from LG, Samsung, Huawei. We were able to achieve very good flexibility and hardness with the nanocomposite invention of mine. Usually the chance to bring the invention to market is like less than 3% in Dow. But I was very lucky. That was my first project, and I was able to bring that all the way to pilot and then secure the commercialization with LG and Huawei. And that encouraged me to just do more similar thing as business R&D. So after that experience in Dow, I decided to go to even faster paced company, Carbon 3D. It's for 3D printing. And while I was working there, there's even a more exciting project from my Dow Chemical coworker in Apple. She's a manager in Apple working on AR, VR, optical materials, and she loved what I was doing. So she recruited me to Apple. And that started my 5-year experience before business school. I invented a lot with my team, the optical materials for AR, VR headsets. For anyone knowing augmented reality and virtual reality, optical materials is the biggest thing. For example, the waveguide material for AR glasses or the display materials for VR to help improve your experience in the virtual world or in the augmented environment. That's just super exciting. But in the meantime, I got the opportunity to get into the Zero Waste initiative in Apple as an advisor. Trying to understand Apple's vision on closing the loop, for example, on their polymer materials in their Apple Watch, or all the critical materials used for any iPhone manufacturing, they want to eventually use completely recycled materials. I realized that, wow, that's exactly the same as my original motivation to study material science because of polymer plastic recycling. And now there's a big need on critical material recycling because of all the shortages and supply chain challenges to make the batteries, all the semiconductors. And that's where I feel super motivated. And yeah, I decided to apply for business school to explore this impact entrepreneurship, focusing on critical material recycling, especially on battery. Unfortunately, I got into Stanford. Stanford is a perfect place for impact and entrepreneurship. Here I am in Stanford, and the past 1 year has been amazing. I originally focused on electronic waste recycling and pivoted to EV battery recycling, and now more on EV battery reusing. So now I founded the CircleBat team in Stanford, trying to find a battery diagnostics way to tell which EV battery at the end of life should be recycled or reused, because we're just at the very beginning on the big wave of the battery waste coming to the market, and knowing which batteries should be recycled and reused and having that intel on battery health is going to be more and more important. That's the vision and belief of my team at Stanford.
You are absolutely right. We are at the very beginning of EV battery waste. It is strategic to think about that beforehand. For people who are not familiar with this topic, could you tell us more about the circular economy and waste management, especially when it comes to EV batteries?
Yeah, definitely. In general, circular economy is the idea that rather than linear, we just keep exploiting the resources and raw materials on this planet. We reuse what has been used and put them back to the value chain for second life or even third life. There are 3 R's in circular economies. In this case, for EV batteries, there are a lot of critical materials used to manufacture the battery. When the battery reaches the end of life, you can recover the materials and remanufacture the battery using the recycled materials. Alternatively, you can also reuse them. So I mentioned about recycling the materials. The second R is reusing. Basically, give them a second life. When the EV battery reaches capacity around 70 to 80%, they will be retired by EV OEM and the market, but can still be used for stationary energy storage, for example, the power wall at your home, or the one used for solar farm or wind farm to store the energy for utility grids or microgrids. They can still be used in those applications for another 10 years. Or you can reduce the amount of critical materials used for battery manufacturing. In addition to the efforts that I'm making for, say, battery diagnostic, for recycling or reusing, people are also thinking about how we can avoid using critical materials for battery to make very high energy density battery. For example, some are working on sodium ion batteries. There's also zinc air batteries that doesn't involve, say, lithium, cobalt, or nickel, this kind of quote unquote critical materials that's very carbon intensive to harness in the planet. That's the idea on circular economy. Basically, the 3R principle: reducing, reusing, and also recycling. And people are trying to find different ways to tackle this challenge. And the main reasons we care about this, and everyone should care about this, is because, first of all, we have limited supply of raw materials. A lot of the waste, battery waste and polymer plastic waste, they actually will degrade in the environment and degrade into toxic materials, for example, microplastics or toxic heavy metals that will accumulate in the food chain. And as they accumulate in the food chain, it will impact our health, our reproduction system, our brain, overall health of this generation and future generation. I really believe that it shouldn't be just some quote unquote sustainability enthusiast working on this problem. It should be everyone start to think about this, because you start to see a lot of news on microplastics observed in glacier or in our food chain, and how it may start to compromise our reproduction system, this will become more serious if we don't really take it seriously.
I agree. The planet itself is one big circular system. Plastics, toxic battery waste. If we humans don't proactively manage and circulate them, nature will do that for us. And that will impact our health. And now I want to dig a little deeper into why you choose to focus on circular solutions for batteries rather than polymer, especially since you have a strong background in polymer and we're still living in a world that heavily rely on all kinds of plastic materials. So why not start polymer related projects?
That's a great question. It's actually one of the reasons I decided to come back to business school. So it's not just about everyone wants to have recyclable plastics and want to work on plastic recycling. And actually, that was my beginning point. But what I find very challenging is that on the business perspective, the value you are generating by recycling is not offsetting the cost. The cost is just higher than the revenue. And it makes it very difficult to have a profitable business. I actually created a marketplace called Treasure, one-stop shop to help people collect the electronic waste, plastic waste, or all the aluminum cans and find the channels for recycling and help them make some money out of it. And there are many technologies to recycle them. When you recycle plastics, it becomes all material again, but the margin you can make by selling this kind of recycled plastic is really low. And same thing for the textile and the electronic waste. The collection and the market is just, the infrastructure is not there. So that makes the cost high. You have to collect the electronics waste and the plastic waste from every household or even certain market segments. And that logistics, the acquisition cost is high and it's offsetting all potentially revenue you can generate. So while I'm still very passionate about all these potential recycling opportunities, I realize that it's hard to make business impacts at this point. And because my goal is, in addition to making environmental impact, I also want to help the stakeholder to generate financial return as well. After all my industry experience, I do believe that's the way to help people. You have to prove to people that this can be a business. You can generate not just environmental impact, but also financial impact simultaneously. I was searching for the best vertical, and that's how I landed on EV battery or just battery in general. The battery is more valuable than the plastics, the textile, or even some of the precious metal and electronics waste. You can actually make it a profitable business. And hence, you are seeing so many recyclers, battery recyclers in the US.
Let's talk more about their second life, of how we are handling battery waste and how the second life battery systems are shaping up.
Definitely. So I will start with the battery types. So in a lot of the EVs, there are this type called NMC batteries with a lot of lithium, cobalt, and nickel. There is also this new battery types called the LFP batteries. The NMC has very high energy density, so that makes the range for EV higher. And it has a big amount of lithium, cobalt, and nickel. The recycling value is also high. So the recyclers can really make it profitable by recycling all these NMC batteries. But as what we just discussed, people are aware of the battery design and trying to avoid using critical materials, and hence the LFP kind of battery is coming out. Still has lithium, but the rest of it is mainly iron, phosphate. So it has a little bit lower energy density as the NMC batteries, but the duration and the safety is much higher. And the LFP battery could potentially offer much longer lifetime in the second life with a higher safety than NMC. So that's the trend that many people see at the end of life. The reusing market could start to gain some traction. By 2030, we will have more LFP batteries, say more than 60-70% in North America and most of developed markets, because they're actually safer. They have much longer lifetime, which can last another, say, 8 to 10 years. Many people in this industry think that there will be a mixture of reusing and recycling, and the recycling technology will keep on improving to make it less wasteful. And currently, 95% of the batteries actually end up in the warehouse and also the landfills. And only 3% are being recycled. Even though we have so many recycling companies like Redwood Materials, Light Cycle, yeah, only 3%. And less than 2% are being reused for second life. We see a lot of potential here, and some reports are projecting that this reusing and recycling will potentially go above 25 and 30% by 2030 and will continue to grow. It's definitely something people start to care about. And I would love to be one of the person in this field to help push it to a more circular and sustainable market. Yeah.
I want to follow up on the data you mentioned. Right now, 95% of retired batteries end up in landfills or warehouses. This is a shocking amount of waste. So, what's stopping us from recycling and reusing all of them? And how do you think this will change in the coming decades?
Yeah, that's a very good question. That's exactly what I'm researching, and hopefully Circubat can help tackle along with the other peers in the market. It goes down to the infrastructure. People don't know where these batteries are. And even though they know, say, there are some batteries at your local dismantler, say your Tesla, but who is going to swap the batteries for you? And who knows where these batteries are? And who is going to test and tell which batteries should be recycled and repurposed? What is the type of the batteries? Who are the recyclers and repurposers? Who is going to transport these batteries from all these different channels to the recyclers and repurposers? All these need to be worked out. And that's why you are seeing a lot of burgeoning startups coming in this market trying to address every piece of the value chain, from understanding where the batteries are to creating the marketplace, matchmaking, reverse logistics, recyclers, and the repurposers. So all these need to be worked out to use these second life batteries. People care about warranty, insurance, lifetime. They need great diagnostics. They also need warranty and insurance company to come into the market and ensure these batteries for second life. So you have all these pieces in the market that try to come together to make the market share of recycling and reusing higher. But currently, it's just not there yet. By 2030, hopefully, we can reach 20 to 30% of recycling and reusing as many pieces of the infrastructure start to come together.
Yeah, battery waste is becoming a serious issue. We have never produced batteries on this scale before, and we don't have the infrastructure to handle this volume of waste effectively. That brings me to my next question. Tell us more about your project, CircuitBat. What exactly is battery diagnosis? Why does it matter? And how does it contribute to this emerging infrastructure?
Yeah, so that's a great transition. CircuitBat is, we've done market research in the past 6-7 months in Stanford Business School. And we see that when the battery reaches the end of life, how are you going to reuse them? You do need to understand the state of health of these batteries. And without the state of health of the battery, you cannot insure them for any application for second life. And some of you who don't know how the state of health of battery pack is determined, it's actually determined by the worst cells of the battery pack, and there are hundreds, thousands of battery cells in the EV battery pack, rather than the average performances of all these battery cells. So that's actually makes it very challenging, because that means you have to measure every cell's performance sequentially, or just do a lot of tests and cycle tests. So that's where we see we could potentially add value to this market if we can simultaneously test a lot of battery cells and understand which is the worst performing cells and use the data to project the lifetime performance safety through machine learning. We can help transition from first to second life. Currently, I'm working with Professor Sinetsky's lab to build a prototype of this sensor array, magnetic sensor array, where we can cut the test time and still maintain the accuracy to get a lot of battery health intel in a very short period of time. And that's what we believe is needed to really facilitate this transition from the linear economy to the circular economy for EV batteries.
But batteries retired from EVs, they're not performing well enough, right? So who is actually going to use them?
Currently, for the EV battery chemistry we're using, say they can last for 300 miles, but based on EV drivers' feedback and the EV OEM industry is that as it reaches, say, 80% of the capacity, the range of your EV is low enough where the consumers start to compromise the driver's experience. And that's where the EV OEM want to help you swap out this degraded batteries and with a new one. But the question is, what do we do with the swapped out battery? So it really comes down to the customer experiences. And the reason there's a second life batteries and people are thinking about second life is because the battery cannot maintain the same customer experience. And we don't foresee that to change in the next 10, 15 years. With that said, the question also becomes then who is going to use all these second life batteries? So currently, a lot of the repurposers that you are seeing in the market, they are using them for the non-critical energy storage application. So for just emergency backup system for telecommunication tower or for all kinds of industrial or commercial buildings. But the question becomes, is there a bigger market to digest the second life batteries retiring in the next decades? And hence with CircuitBat, our vision is to help unlock the on-grid markets, either microgrids or utility grids. We do see that will be the scalable and the biggest market to tap into. But the question becomes how. The reason that is not tapped into is because they need to be warranty insured. And to get that warranty and insurance, you actually need them to be certified by, say, underwriter laboratory, the UL certification, say 1973, 74 certification for the battery, and the entire energy storage system with a second life battery also need to be UL certified. And you may be surprised, currently in North America, only Moment Energy in Canada has UL certification for their second life batteries. We are hoping to provide even higher quality and higher quantity battery cell data for not only UL certification, but also for warranty and insurance. And with that, you can confidently reuse them for utility grid or microgrid, the on-grid applications.
Thanks for showing us how you approach this problem. You're always thinking one step ahead and asking questions that are truly need driven. So, what is the biggest challenge for you at the moment? Is it the market, the technology, or something else?
Good question. Definitely technology we're still developing in Stanford, so it's still lab scale technology. So the focus this upcoming quarter or so will really to mature the TRL of the technology and demonstrate the feasibility for bigger scale testing with cell level diagnostic technology. The second is definitely the market and customer discovery. It's a new market. Utility grids and microgrid players love the idea. They like that the second life battery could be cheaper, but it's new. They want it cheaper, insured, and warranty. They think this is something we want to try. But the question is, are they going to try? And how are we going to also build the confidence with the insurance company to provide performance asset insurance for the second life batteries? And even with that, how are we going to test it on grid and build a pilot? So there are several players in the field that are trying to tap into the same space. I think it's great. We're all trying to make an impact, but it's not easy because the market is still forming. There are also many other market segments for reusing. More and more applications will open up. For example, even residential. If the battery OEMs start to have more standardized EV battery configurations down the road. So yeah, when you are dealing with a forming market, it's always tough because you have to work with many stakeholders to mature the infrastructure and value chain, demonstrate value to your potential customers, which takes time. So
Yeah, it's tough, but you're at the forefront of this emerging market. I feel excited for you. Now let's talk about the community. I know you have worked closely with Stanford Impact community. What are the interesting things you have learned?
I'm amazed at Stanford's impact community. I never met this many people that are so keen and passionate about making impacts. I was able to look at impact from the investment side and also from the entrepreneur side, which is such an enriching and enlightening experience. I think to really make impact work, I do think the investor and the entrepreneur need to work hand in hand. The impact assessment is still maturing. And institutions like Stanford and many impact investors and other academic institutions, everyone is trying to improve impact assessment metrics and framework every day. I'm just amazed at how people are pushing on this front. Having a holistic way to assess the impact along with the financial return. It's important for not just the investor, but also the entrepreneur. And I was fortunate enough to look at this from investor's perspective and also from entrepreneurs' perspective. So I think that's one of the biggest thing I learned. Some challenges I'm also seeing in this community is the framework is still maturing. People are still trying to see where is the biggest impact and where the impact is aligned with the financial return, and to build that track records and the trust with the LPs and with different kinds of investors and build that pipeline. Building this pipeline together and really maturing the due diligence, finding the right metrics and learn from the mistakes from the past, say investment or new venture, I do think is something important for people in the impact ecosystem to learn and keep improving based on this learning cycle. It's tough. It's very tough to make impact and financial returns simultaneously. And we've seen patterns how the previous ventures in this field are learning and feeding back that learning to future investors and entrepreneurs is important.
All right. I think we're wrapping up the podcast now. To end, we have got 2 questions we ask every guest. First up, what keeps you up at night?
Yeah, definitely the future of battery circularity keeps me up at night. Looking at this 95% EV battery number going to the landfill, it's not a great feeling.
Fair enough. And the second question is, what makes you feel hopeful?
I think this 1 year at Stanford and every people that have been supporting me and that have talked to me, I see people care about this. And as time goes, I only see more and more people joining this community. Every time I go to conferences, workshops, social events about climate, I see new faces, new people, new blood injected into this ecosystem. And I think that just makes me feel grateful, motivated, and feel very hopeful about our future.
Thank you so much, Joseph. That brings us to the end of this episode.
Yeah, thank you, Ellen, for the great conversation. If anyone has questions about what I'm doing or circular economies in general, just reach out.
That's all for this episode. Be sure to subscribe to our podcast. If you want to explore further on this topic, use the link to read more. Our guests picked out additional materials for you.
So, until next time, stay informed, stay inspired at Climate InnoPod.